Alright peeps, a very exciting video for you because in this one we are going to learn how to graph without having to plot every single point that we want to graph. So we're going to use some of the knowledge that we learned in a previous video. So first things first, when we want to graph a function, we need to learn to use the vertex formula. Now some teachers teach it as only using that formula for certain types of quadratic equations. I use it for all of them until you generalize a pattern where you're like, oh, okay, I know where the vertex is going to be. So the x value of the vertex is always going to come from this formula, the opposite of b over 2 times a. And you might be like, what is b and what is a? Well, remember the general form of a quadratic equation is y equals ax squared plus bx plus c. So you take the coefficient of the x term, take the opposite of it, and then you divide it by 2 times the coefficient of the x squared term. And that is how you get the x value of the vertex. So I always start out by finding the x value of the vertex, and then I find the y value of the vertex. We'll get to that one shortly. And that then gives me a lot of information. Let's do it. So the vertex, and I'll just put that as the first thing that I do. Well, this is y equals x squared, but technically it's plus 0x plus 0, right, if there's no other numbers. So what is the b value? Well, it's 0. So b is 0, so we get x equals the opposite of 0, which is just 0, over 2 times a is 1, right? There's a little invisible 1 right there. So all over 2 times 1. 0 divided by 2 is 0. What that means is this is the x value of your vertex, which also means that your axis of symmetry is x equals 0. As we saw in a previous video, the axis of symmetry goes right through the x value of the vertex. So my axis of symmetry, I like to draw in there first. Every single stinking time. Sweet. So I get my axis of symmetry is along the y-axis. So I also know that my x value of my vertex is 0. So if my x value is 0 and I want to know what my y value is, all I have to do is plug 0, the x value, into the original function. So that would be y is equal to x squared. We take that and we do y equals 0 squared, because I want to know what the y value is that corresponds with that x value, which is equal to 0. So I now have a vertex, a little sideways, of 0, 0. Now, before we move any further, what we should note, and I'll make that a different color, is that that vertex will be a minimum. And you might be like, well, how do you know that this is a minimum? And I'll just call it a min. It's the function y equals x squared. The a value is positive. It's greater than 0. So we know this graph is facing up, making this a minimum because it is the vertex. It'll be the lowest point if it's facing up, right? Ding, right there. Okay, so now we need other points. How do we find those other points? Well, we're going to use the fact that this graph is symmetric about the y-axis. So I pick 2 other values as close to the axis of symmetry as possible. So you can either pick -1, -2, or 1 and 2, but I pick them on one side of the axis because if I pick 1, I would expect to get the same exact value on the left side because of the symmetry that's going to happen. So there's no point in plugging in -1. You know what that y value is going to be once you have 1. So I plug in x equals 1, and I plug in x equals 2. And I plug that into y equals x squared. So that's going to be y equals 1 squared, which is equal to 1. And so then the point that I get out is my input is 1. My output is 1. Sweet. So I know that one point on here is 1, 1. And I'm going to use the fact that this is a mirrored graph, symmetry about the axis of symmetry. So it's 1 away from the axis, 1 away on the other side, just like a mirror. And then I'm going to do another point. I like to get 5 points. So I plug in 2. 2 squared is 4. My input is 2. And so my output is going to be 4. So that's going to be the point 2, 4. And then that's 2 away from the axis of symmetry. So we'll go 2 away on the other side. And there are my 1, 2, 3, 4, 5 points. The nice part is when you're doing this graph, and of course you got to connect the points, right? Got to show that there's continuity between all the points because you could plug in like 1.1 squared and get a number. It'd be somewhere around there. So the whole purpose of this is showing you that you don't have to plug in tons and tons of points. You find the vertex. After a while, you're just going to look at graphs like this and say, well, there's no b term, so my vertex is going to be at 0. There's no c term, so my y value is 0. And then you're good to go. So you'll end up speeding this process up even quicker than what I showed here. And that's the whole purpose. So you don't have to plug in tons and tons of points. All right, I'm going to continue in this video. It's going to be a lengthier one. I have 2 more graphs to show you. I'll go a little quicker in those. In the second graph, we'll start right now. So if at any point you're like, I've had enough, then you can always turn off the video. But I wanted to give you plenty of graphs here. F of x equals negative 2x squared. Remember, f of x is the same as saying y equals negative 2x squared. Again, we're going to start out with the vertex. So the x value of the vertex is the opposite of b over 2a. Remember that in this case, we have that a is negative 2, b is 0, and c is 0, because there's no terms there. So that's going to be 0 all over 2 times negative 2, which is our a value, which is just 0 over negative 4, which is 0. Okay, so our x value is now 0 of our vertex. Our axis of symmetry is x equals 0. So I'm going to go ahead and mark that all along this graph, and hopefully you can see that nice and thick. That's going to be what allows us to use it as a mirror, right? Sweet. So now if I want to know the y value, I just plug x equals 0 into this function right here. Not bad. So I'm going to show that notation as f of 0. Remember, that just means plug 0 in here, which is negative 2 times 0 squared, which is equal to 0. 0 squared is 0 times negative 2 is 0. So again, the vertex is 0, 0. I'll put that in a different color right here. So there's your vertex. Now because a, we'll take a look at the graph again, or the function again. Because the a value is negative, right, a is less than 0, that's negative 2, we know our graph's going to be facing down, and it's going to be fairly steep because the 2 is bigger than, well, the 1 times x squared that's normally there. So that gives us an expectation of what to look for. So what values will I plug in? Again, I like plugging in positive numbers where possible. They're easier to use. I pick 2 x values to the right, 1 and 2, and I will mirror them once I get them out. So I'll do f of 1. That's negative 2 times 1 squared. Remember, I have an x value that I've chosen. Some students will ask, how do you know to choose 1? I just don't choose larger x values because that'll give me very large values out of here that won't fit on my graph. That's how I know. So I choose the x values as close as I can to the axis of symmetry. 1 squared is 1 times negative 2 is negative 2. So that means my input was 1 and my output was negative 2. So that's the point 1, negative 2. And we'll mirror it. So that's 1 away from the axis, so it'll be 1 away on the other side. Sweet. We'll now plug in f of 2, or x equals 2, into f. So that's going to be negative 2 times 2 squared, because that's what the function does to these numbers. Using the order of operations, 2 squared is 4 times negative 2 is negative 8. And that leaves us with an input of 2 right here, and an output of negative 8. So that's the point 2, negative 8. So 2, down 8, bam! We're 2 away from the mirror, or the axis of symmetry, so we'll be 2 away on the other side. And now this is actually the worst part for me, is trying out the parabola, because I can never quite hit all the points. There you have it there. As expected, a parabola that is facing down and is narrow, and I'm giggling because I missed these points completely right there. All right, that's it. Find your vertex and axis of symmetry and put them on the graph. Then plug in 2 points to the right or to the left of the axis, and then mirror them, and you've got yourself your parabola. One of the most important things that you should be doing when doing these problems is making sure that you just take it a piece at a time. And when you're done with the piece, graph it. Don't wait to the end to graph it. I think that by doing it visually along the way, as I did it, found the vertex, plotted it, found the axis, plotted it, that will remind you as to what you're doing and why you're doing it. I am going to do one more graph. But again, if you're like, nah, I'm good, then that's fine. This one more graph, let's have some fun with it, is y equals 1/4 x squared. So I, again, will find my axis of symmetry and vertex. So the equation is the opposite of b all over 2a. Again here, we have no b term. Where did that b term go? And we have no c term. But that doesn't matter on this particular graph. We'll talk about that in a later video. So b is 0, the opposite of 0 is 0. All over 2 times, 1/4. What is that going to be? Well, it doesn't matter because 0 divided by any number is 0. So that again is our axis of symmetry. I think we're starting to see a pattern here that when it's of the form ax squared, your axis of symmetry is always at x equals 0. Mark that one down and generalize it. Very cool. And we'll see what happens and what makes these vertices shift left, right, up, and down in later videos. So if x equals 0, I'm just going to plug that into y equals 1/4 x squared. and that will give me the y value of my vertex. 0 squared is 0 times 1/4 is 0. I think we kind of expected that. So our input was 0, that was the x value, our output was 0. So I'm now going to plot my vertex. Remember, plot the information as you receive it. Then we're going to plug in 2 points. Again, I plug in 1 and 2 because they're two immediately nice numbers to the right of the axis of symmetry. So y equals, we're doing 1/4 x squared times 1 squared. 1 squared is 1 times 1/4 is 1/4. So our input was 1, that's our x value. Our output was 1/4. Sweet. And now our input, you know what, let's plot it. Sorry, got a little ahead of myself. So 1 comma 1/4 is like there-ish. Negative 1 comma 1/4. Looks like it's wider than the other graphs we've done so far, which makes sense because, as we saw in a previous video, the smaller this fraction is, the wider the graph will be. It slows the graph down. It doesn't rise as quickly. So, and if you're like, wait, why is that? Then check out my earlier video in this lesson on why that is. Okay, so we're going to now plug in 2. 1/4 times 2 squared. 2 squared is 4 times 1/4 is 1. And if you're like, how do I do that math? Feel free to use a calculator or do it out piece by piece like this, right? And that equals to 1. Okay, so now our input was 2 and our output was 1. So that's the point 2 comma 1. Ooh, it's very wide. That's a mirrored image, 2 to the right, so we're going to go 2 to the left. Ah, look at that wide parabola. Ooh, look, I'm getting better at drawing them. I don't want to get too cocky though. So we expected it to face up. We knew our vertex was going to be a minimum because it was facing up. And we knew it was going to be pretty wide, as discussed earlier in the video. There you have it, peeps. 3, count them, 1, 2, 3 examples of how to graph parabolas. We're going to go in later videos and see how to graph other kinds of parabolas when we have a c value and then a b value.